So, my name is Don Syme, and I'm a researcher at Microsoft Research in Cambridge. And, I've done quite a lot of things in my time here at Microsoft. At the moment, I'm just over here visiting in Redmond, and thanks to my good friend Damien, who's sitting over here, I've got the chance to do this Channel 9 interview, so thanks. And I'm over here visiting headquarters, particularly for the Lang.net symposium, which was run by Eric Meyer. This is a fantastic event where we got language designers from a whole range of .NET languages, and actually some non.NET languages as well, together to discuss language design issues and implementation issues, and to show off sort of the latest stuff like say PowerShell and Python and F#, which is a project that I'm working on, and to show off these various things and to kind of connect and share ideas in the applied language development kind of space.
Right. So you've been at Microsoft Research for about 8 years, is that right?
It's been 8 years now, yeah. I joined in 1998, just back in the days when .NET was just starting, before it was called .NET, I think before it was called Lightning even, and we saw that there was this fantastic opportunity to engage with the design of what has now become such a sort of crucial part of the infrastructure of the software industry. And I engaged with .NET through a guy called Andy Gordon, who is also at our lab, and we did some projects to sort of analyze some bits of the design, and then we saw an opportunity to sort of propose extensions to the design, sort of crucial extensions, and in particular we proposed. In 1999, I proposed to do generics for not just for one language like C#, but actually to do an interoperable and efficient sort of version of generics, where the process of instantiating generic templates is sort of managed by the Common Language Runtime. So we took this idea and we prototyped it, and after a lot of hard work, a lot of engaging with product teams, and eventually they signed off on it, and we have this. We now in Visual Studio 2005 have this fantastic feature which sort of shipped last year, which has been a real highlight for us in our time.
So it took from
Microsoft.
It took from 1999 to 2005 to get that in.
Absolutely. Now, and I was under no illusion at the start about how long these things take. I've worked in the research labs at say Intel. Back in 1996, and I really saw what the technology transfer pipeline is like, and you need just a good pipeline of ideas and possible ideas to transfer in, and you need people who will work through the process of making those ideas actually work in the real products and in sort of real deployment.
So how much of what you work on translates into shipping in a real product, and how much of this is just pure research kind of technology?
In our lab, we have a fantastic mix of pure research and sort of more applied work. I certainly work on the more applied end, but it's extremely good for your mind and soul to kind of work across a spectrum from sort of pure research through to applied research. But for my work, I definitely am working at the moment in sort of applied language design and development, both through the generics project and through F#, and through sort of these projects. It's not always just about the one technology that you're developing, but about how that idea can then influence what other people do in other settings. And so it's not just about making a piece of software and shipping it. It's also about showing that something is possible, or exploring a space until finally the industry is ready to adopt some sort of new set of techniques, as in generics, for example.
Right. So that brings us nicely on to the subject that we're going to be talking about today, which is F#.
Yeah.
So
thanks for the chance to talk about this.
Of course.
Yeah.
So give us some background. Why do we need another language? What is F#? Why even F?
Yeah. So the F is for functional, right? And it's not actually a word I use to describe the language much, because F# is really what I would think of as more a function-oriented language, in the same way that object-oriented languages are object-oriented. It's certainly a multi-paradigm language. You can do object-oriented programming, you can do functional programming, you can do imperative programming, and sort of one of the aims of the project is to try and bring these bring these techniques a little bit closer together to show that there's not as much sort of tension between these different paradigms, but actually that they play together nicely, and in many ways are quite orthogonal. So functional programming for me hits an absolute, it hits a sweet spot in productivity, and a particular kind of, I've been for a long time engaged in a particular kind of functional programming, which is in the tradition of what's called these ML family of languages like OCaml or Standard ML, and so lots of related languages as well. And I think this style of programming hits an absolute niche in productivity for, in particular for kind of advanced developers who need a tool, programming tools to kind of capture the complexity of algorithms, and in particular symbolic manipulations. So if you're working with trees or tree-structured data, or doing kind of analysis over large symbolic sets, these kind of languages have always sort of hit the mark really nicely. It's trying to get some of what you get in Lisp or Syme, and a fair bit of what you get in Haskell, and making that work as well as possible in the context of the .NET platform.
Right. So is this going to be a new shipping language added into Visual Studio 2005 or Orcus or something?
So what we do is, it's a research language, but I think of it as a high quality research viable research language, viable for use in appropriate settings. So there are places like it's used in Microsoft Research, for example, to do analysis of the data coming out of the Xbox Live services, to kind of do the player ranking of who should play against who, and they use it to explore algorithms, and also to put together applications which can then be run by the product teams on their servers. So there are kind of niches where it's often to do with individual, as I said, sort of individual, say scientists and engineers, kind of trying to deal with large data sets, because it's a very efficient language. It's sort of like a scripting language, but it's also extremely efficient in the same way as C#. And you're also sitting on these wonderful .NET libraries, which I say do very efficient I/O or database access. And so when you give the sort of individual or small teams these kind of tools to do their data mining analysis, then they're able to get an awful lot of work done, which is kind of what we're aiming for.
So you mentioned this is a research language.
That's right. Yeah.
And it's downloadable. People can get it today.
Yeah, that's right. So when I say a research language, I mean it's a language whose home is sort of Microsoft Research. So it's definitely like an add-in to Visual Studio 2005, for example.
Right.
You kind of get the download, and you work with your visual tools and so on.
Could I build a commercial shipping application using this language?
Legally, I mean, I don't know how much we discuss legal sort of things on this kind of setting, but the license permits commercial use of the programs you've produced with using F#. It's definitely we're set up for that kind of work.
Right.
Yeah, but it's certainly not the sort of thing you'd roll out for line of business applications or something, or deploy across a whole company or something. We're not aiming for anything like that kind of niche.
Okay. So who do you think would be using this language, and what do you think they'll be doing with it?
So I like. That's a good question. I wasn't prepared for that one. You have to edit that one out. That's such a hard question to answer. Can we skip that one?
Sure.
Yeah.
So instead, why don't I ask you, who do you think will be using this language? Okay, so let's ask a different question.
Because I always leave people to make their own decisions about that. Like I'm really cautious about that. Like my approach is to put out something which is strong technically, and it's actually quite a multi-paradigm, actually very good for a range of things. But the borderline of when people switch to moving to using a new language is very, very context dependent. Right? It may depend on the training of the people involved, or even the preferences and all the other tools they depend on, and the kind of data they access, or the legacy software that they have. But I think your question is what kind of people. I mean, certainly anything in sort of problem solving with structured data. This is traditionally the area where functional programming has had a real massive, really large productivity gain for.
So if I'm today a C# developer, are there particular problems or application types that I should consider potentially using F# for instead?
So the feedback I've had from so we get a lot of C# people coming and looking at F#, and one interesting thing that I get is they do some F# programming and they actually feel like they learn something different about programming, which actually improves their C# programming as well, because it's kind of a concept. It feels conceptually sort of different about how you manage complexity, how you manage say through the use of function values and closures and sort of the compositionality that you get between certain elements in the language, and that makes them they kind of helps. I've been told it helps them think about C# or VB or whatever in a different kind of way.
Right.
Which from a research perspective, that means a lot to me, because it's not just about the language; it's actually about ways of thinking as well.
So do you think some of the language changes between C# and F# may migrate into a future version of C#, or do you think F# will end up being a standalone language?
Absolutely. In a way, you can see generics as being an example of that. We knew generics was a powerful feature. It had been invented in many developed in many different languages, but we knew the importance of it through our work with these kinds of languages, with languages like F#. And that was one reason why our team was Andrew Kennedy and myself and Claudio Russo at Microsoft Research in Cambridge were so keen to see this through into the product in Visual Studio 2005. Because we just knew what a powerful thing it was. As for other features that come out of F#, so for example, it kind of goes both ways. So one of the things we've added to F# recently is support for link. But we do it a bit differently. But we do it in a way that hopefully can help inform sort of future designs or future developments in the link kind of area. I mean, when I say future, I mean 3, 5, 8 years out.
Right.
It kind of, these things can go around in the cycle. We get a lot from industry, and industry hopefully gets a bit from us.
So the conference you're at this week in Redmond, were you talking about F# at that conference?
Yeah, I was. Yeah.
And what kind of feedback or comments did you get from people about F#?
I had a really good feeling in the room. I think people understand that it is possible to have a very succinct language where you don't have to write so many types. I mean, one of the key things, there's a big move towards dynamic languages, right? And one of the key things that's driving that is that people don't want to write type annotations on their code. It's kind of like the process of writing types can be just quite burdensome somehow, especially for scripting sort of applications. But it's always been assumed that you had to give up on performance to do that. That you had to move to some sort of interpreted kind of language. But the real niche of these ML languages, and if you go right back to the first designs of ML, what it was for. So F# is a version of this language design called ML, and they were designed originally to do interactive symbolic manipulations. So they would have these big logic expressions which represented, say, like a specification of a piece of software, and they'd be trying to sort of do manipulations on those to kind of eventually prove that some bit of software met its specification. And these manipulations were sophisticated enough that the input programs had to be typed. You had to control, otherwise you'd be making mistakes all over the place. But you can see right back at the start, it was a type-safe scripting language, and in a sense we're still trying to hit that niche, but in the context of .NET, and when we get people say doing machine learning with the language, they're doing a similar kind of thing in a way. They're doing sort of interactive investigations of data, which are sophisticated enough that you need types, and you're running over large enough data sets that you need the performance.
Right.